Alright, let's go ahead and read the problem. Day 3, gear ratios. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, oh boy, is a part number and should be included in your sum. Periods, dots do not count as a symbol. Here is an example engine schematic. Of course, the actual engine schematic is much larger. What is the sum of all the oh, okay, this sounds interesting. This is this year's first 2D, I guess, textual problem. I think the strategy here is pretty straightforward. What we want to do is iterate through each line and find the numbers and then look adjacent, so up, down, left, right, diagonals, to see if there's any symbol that touches it, and if there is, we add it, and if there's not, we don't add it. Now all that's missing is we need to find out if the number is adjacent to a symbol. So that's fun. So let's do let mute is besides symbol equals to false. And then what we want to do is check. There's like the simple cases and then there's the more complicated cases. The simple case is going to be left, right, and then the 4 diagonals, because those are always going to be there. And then the more complicated ones are going to be, I mean, they're not really that much more complicated, just more annoying. Are going to be the one, the neighbors directly above and below, because we're going to have to iterate. Actually, now that I think about it, I just have to look in the box. I don't have the box surrounding this. I don't have to like be clever about my pathway, so that's pretty straightforward. Cool. And then here, if is besides symbol, we just want to add up the part numbers, so part number and let me x equals to 0, and then we return s, and we should be good, except for the fact that I certainly have this syntax here wrong. Right, that's annoying. Does that work? No. I will discuss it. So what I have now, this is new size, and then ASCII stir cannot be indexed by so I have to do something like that. As I don't know, size. So as ASCII size. Why is that not allowed? Chars that just ASCII string to char array. That must be a thing. That must be a thing. ASCII string from ASCII roundbar as bytes, as pointer, as stir, as bytes, as slice. That's what I want, as slice. slice. There we go. And then I do is digit, and by this I mean is ASCII digit. And okay, so that should be good. I also want to check VS Code keyboard shortcut to switch a terminal exactly. For Mac users, command tilde. Cannot be command tilde. That's the keyboard shortcut for switching windows. Yeah, it's not working. The control tilde? No? Maybe. Oh, sorry, undo. Oh yeah, it is. Okay, control tilde is the answer. Save. And let's get our example input. So, copy. Oops. Example.txt. Day 3. Save. Let's see if this works. Example.txt. Oh my god, why are we unhappy? Expected I32, found U32, who cares? I just want a number. Four, 3, 6, 1, that's correct. That's exactly what we see here. So let's get our puzzle input. That's fun, it's wrapped around. Save input.txt, save it in the D3 directory, and let's run it. Input.txt. And that's my answer. Correct, perfect. First try. What's the time? 23 minutes. Alright, the engineer finds a missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast though. Maybe something is still wrong. Unfortunately, the gondola has a phone that will help you pick it up and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. Oh no. The gear is any star symbol that is adjacent to exactly 2 part numbers. Oh no. Okay. Okay. Its gear ratio is the result of multiplying these 2 numbers together. This time you need to find the gear ratio of every gear and add them all, so you can find out which gear needs to be replaced considering the same. And in schematic again. In this schematic there are 2 gears. The first at the top left. That's part number, so that's gear ratio. What is the sum of all the gear ratios in the engine schematic? So the reason this is annoying is because this is slightly tricky to do with the way we've done the parsing here, which is by we first find the numbers and then we find if they're next to any symbols. To do this efficiently, we would want to look at each symbol and then look around it for part number. Let me think about this. I mean, I guess it's not that tricky. We just look for gears. Then we look around the neighbors for numbers. The first number we find around it, we have to kind of grow our numbers. So let's say we're the star. The first number we'll find is the 7. That we're gonna have to look backwards, so all the way until we see the 4, and forwards. So here there's nothing behind it, but if there were, you'd have to keep looking. And then you have to go find another number that's not part of your first number. And that's kind of the tricky part. But I think it's doable. Same thing, and then for example here, you would need to look down, see this 5, and then you would need to grow it, essentially. Same example input, okay. Alright, let's do that. ASCII string. So it's going to be similar, except we're going to start by this. So we're going to go to each line. S is a, why is S a U32 again? Just part numbers are U32, okay, I guess. We're going to go, but instead of finding its ASCII digit, let's take all this out. Instead of asking if it's an ASCII digit, we're going to ask if it's a star. So if line, what? Okay, if line colon index dot equals to char star asterisk asterisk, and then we need to start doing some clever stuff. So let's just find all the part numbers that are adjacent to it, and then after that we'll count if there's two. Why should I install my tools? I want to do that. And because we're good at writing software, we're going to separate that into its own program, into its own function, I mean. So let's create a function find adjacent part numbers. Kind of wordy, but that's okay. Lines takes a vector of ASCII string. Also a line index and a column index. Gives me a vector of part numbers. Part numbers are U32s. Okay. Okay, so then, and let's to do that. Alright, that's adjacent numbers equals to adjacent part numbers, lines, If adjacent numbers dot length is equals to 2, s plus equals to adjacent numbers 1. Okay, now we just need to implement this function. So we know that we're at line index, we're here. So we need to do the same thing we did before, where we iterate around a box, in a box around. So let's do that. Let mute start call. Equals to call IDX and IDX2 minus 1. Let's do the lines first. No, sorry, that's correct. Plus call IDX. Okay, for line start line data. Call in start call in call. Okay. Actually, let's not iterate it this way. Let's do a while instead, because that way we can like skip the column number forward as needed. I guess the query line doesn't really need to change, but this line does need to change. Let query call equals to start call. Okay. That's not really blocking while query call less than call. Actually, less than or equal to end call. Is that right? Yeah. Let's go with that. We have to check bounds anyway here, so I think this is fine. Okay, so here we want to look for a string, for a digit. If it is a digit, we're going to look far back and then far forward to see whether or not it's a number. So line, okay, let's give it a name. If query char is the lines, query line, dot slice, query call, and we need to, this is going to throw if we are indexing out of bounds, so we should check that first. If let's do the bounce check here. Stub line equals to, is there a max function somewhere in Rust? CP, okay, so start line equals to stud compare max. Just to make sure we don't index too far there. And so here, stud. Okay, I guess we can do the same thing here. Oops. Lines. What? That's not it. Is that okay? No. Okay, so no more bounce checking needed. This should all just be valid. Good stuff. Let's query char, okay, and then we do if query char is
ASCII digit. Search to find first digit. Equals to query call. Well, first. Nice one. Well, first digit is greater than or equal to 0, and lines, query, line, value size, done with slice. My god, Rust needs so much typing. What is ASCII digit? First digit minus equals to 1. Okay, and we do the same thing, but right word. Whoa! What did I do? Where did I go? Undo. Okay. Last digits. Except this time we do plus and we check that is less than lines. Size dot length. And we print it. And then we do a query call is equal to the last digit. And then query call is the last digit. This one. Yeah. So I do query call. Just think right one. Yeah, so this should work. Of course, when we found this, what do we want to do? We want to actually like, add it to the list. So list of part numbers. So we're going to do that push. First ASCII lines. Okay. Query line as size. Dot slice. First digit that equals to last digit. I think we can do that. Can we do that? Okay. We need to do this. No? Okay. It's actually because this is a. It's actually because this is a precise thing, isn't it? The bound U32 from saying. That's it. As bytes. We need a type annotation that's easier to do B. This should actually just work, I think. Yeah. I'm gonna clean this up first. This expression appears way too many times. So let's do this. Let line equals to borrow lines query line exercise. And let's replace all the instances of that with that variable instead. Nice. Okay, switch here. Wait, we don't have to actually call this to. Let's do P2. Why does calling index never get implemented? That seems important. Why if I do okay, this doesn't, we don't have to do that, so we have before calling it in 0 dot line dot length. Yeah. And I think everyone should be happy. No crashes. Ah, that's a crash. Slice index starts at thing but ends at 4. Okay, line 103-ish. Starts at like some million, but not 3. Oh, right, because the first index might be actually the first and last index, like it might be single digit. So okay, let's try it again. What? Should fix that. Okay, let's think about this. While first digit. Okay, I see the wrong. Let's get it right here. Okay, so let's not call this the first digit. Let's call this the prior to first digit, I guess. Before first digit. Let's call it the before digit. And we want this to do this. Kind of ugly, but. And then let's same thing here. Let's call it the after digit. After digit. Before digit. Why are we happy with that? Maybe it cannot be next by, but that we want to do that. What's the U size? Oh. This very common thing is it's just after digit. Okay, I think that should be correct. What? Still? 103, attempt to add with overflow. Attempt to add with overflow. What? Okay, that doesn't help me at all. 103. 4 digits as you size. Okay. Ah, this is so stupid. Oops. Don't do this. Okay.
Is that what we expect? 4, 6, 7, 8, 5, 3. Perfect. So let's put it on that. This giant number. And good, we're done. Alright, thanks everyone. See you tomorrow.